How many members of the set shown above are multiples of 6, but not multiples of 9? Okay, so the first thing to do is lay out the set, filtering it for the multiples of 6. I want to do that on paper, just so I'm very careful that I include all the elements of my set, whether they're endpoints or not endpoints specifically. So the first multiple of 6, oftentimes not shown when there's ellipsis there, is going to be 6. So the first element in my set that's a multiple of 6 set is going to be 6. Now it's 12, then 18, 24, and I keep going up by 6s until I get 200 is not a multiple of 6. Also has to be a multiple of 3, which means that sum of digits have to add up to a multiple of 3. So 198, that looks like it's a multiple of 3. It's even, so it's also a multiple of 6. So this goes up to 192, 198. These are the elements in my set. If I want to count how many of these are, one way I could do that is simply divide every number by 6. That would give me 1, 2, 3, 4, all the way up to essentially what would be 33 times 6, 32 and 33. So I know the number of elements in this set is going to be 33. Okay, there are a couple different ways I can do that. Actually, there's several different ways I can do that. Another one is I notice in an arithmetic sequence. So I can use my arithmetic sequence formula. AN equals A1 plus D times N minus 1, where D, my common difference, is plus 6 for every new term. My AN, in the absence of knowing N, is going to be my last term, 198. My A1 is my first term, which is 6. And we know our D is 6, so we're going up by 6, and now I can solve for the number of terms. So that equals 6 plus 6n minus 6. Those cancel. 198 equals 6n. N equals 198 divided by 6, which is 33. The same result we get from our other method above. Again, we could use a range method. You just have to be very careful of getting the endpoints included or not included. We could use a grouping method, maybe grouping by 10s or 20s or something like that here. That would be consistent and make sense. There are multiple methods for counting. Okay, so you want to be aware of all of them and the nuances of each, because counting is not always as simple as students might take it for granted to be. Okay, so this is the first part, but I need to exclude my multiples of 9. So how am I going to do that? Well, the first thing I'm going to do, I'm not going to count the multiples of 9. So do not simply write out the multiples of 9, 9, 18, 27, etc., all the way up to 198. That count is not the count of the multiples of 9 that are also multiples of 6. This is merely the count of the multiples of 9. So how do I do that? Well, I've got my set laid out already, so I can just say 18 is my first multiple of 6 and 9. And then it would be 36. And then it looks like we're going up by every 3 terms. And eventually we're going to end at 198. Okay? Another way to think of it is the LCM of 6 and 9 is 18. So every 18 is going to be a multiple of 6 and 9. So what I might do is lay out this set separately. 18, 36, 54, 72, all the way up to 180, 198. And again, I kind of do the same thing. I could divide by 18 and that will give me the number. So that's 1, 2, 3, 4, that's 10 and 11. So I can see there are 11 elements in this set. I also could use my arithmetic sequence formula again. I could say AN equals A1 plus D, my common difference, times the number of terms minus 1. AN, in this case, my last term, is also 198. My first term in this case is 18. And my common difference is I'm going up by 18 each term. So that's 18 times n minus 1. Note each term adds 18 to get to the next term all the way through. That's your common difference. Okay, so I'm going to get 18 minus 18 when I multiply that out. So 18n equals 198. Divide through by 18, you get 11. Again, the same answer we get over here. So now I have my count for the multiples of 6. I have my count for multiples of 9 that are also multiples of 6. I've clearly laid out the sets. That's important to stay organized. So now I just simply take the difference of the two. 33 minus 11 is 22. That is the answer to the question. There are 22 members of the set that are multiples of multiples of 6, but not multiples of 9.